Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam exam and other exams related to physical science. And also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures which are going to help you to crack the exams related to physical science. So this is the lecture number 15 of mathematical physics. Okay, so I'm going to start now. The one question in previous lecture was left because of technical error. My class was ended, right? So now I'm going to solve that question first. Okay, so this is the lecture number 15 of mathematical physics. Okay, and this is the sixth part of the matrix. Okay, just let me check the voice first. Right? Yeah, yes, I'm audible. Okay, so I'm going to start. I'll write the question first. Very good question. Okay, which I have already explained in my previous class. The question is, which is asked in CSIR NET 2017 December. Okay, CSIR NET December 2017. Okay, question is, this is matrix is given one homogeneous matrix equation is given 1 2 3 2b 2c. Okay, x y z equal to 0 0 0. Okay, this is homogeneous matrix equation. Okay, so you need to find condition for non-trivial 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 solution. Okay, so you need to find the condition for non-trivial solution. Non-trivial means which has many solutions. Okay, and corresponding solution. Corresponding solution. Okay, so you need to find out condition for non-trivial solution, means condition for many solutions for this equation, and with condition you need to find out this corresponding solution as well. Okay, and options are given. Option number A is b equal to 2c. This is the condition, and solution is x y z equal to 1 upon root 6 to 1 minus 2 and minus 1. Okay, option B is C equal to 2b. C equal to 2B, and the solution is x, y, z. X, y, z equal to 1 upon root 6, 1 upon root 6, 1 comma 1 minus 2. And option C is B equal to C plus 1, x, y, z equal to 1 upon root 6, 1 comma 1 minus 2. Okay, and option D is C equal to B plus 1, and x, y, z equal to 1 upon root 6, 2 comma minus 1 comma 1. Okay, so these are the options which are given, and you need to find out condition for non-trivial solution and corresponding solution. Okay, well, so I'll solve it now. Solution is, okay, first we'll write in this form: ax equal to ax into c, right? So this is going to be 1, 1, 1, 1, 2, 3. This is 0, right? 0, 0, and then 2b, 2c, 0. Okay, 2. So we have written this in this form. Okay, a proportional to c. Okay, next is, so here the condition for non-trivial solution, non-trivial solution. Non-trivial solution means it has many solutions. Okay, and for non-trivial solution, if it has non-trivial solution, or it has many solution, that means rank of this matrix, rank of the matrix is less than n. Okay, order of the matrix. Okay, if that is the case, that implies determinant of A equal to 0. So it means for non-trivial solution, determinant of A equal to 0. Okay, so now so determinant of A equal to 0, A is this matrix of coefficient matrix, that is 1, 1, 1, 1, 2, 3, 2b, 2c. Okay, this one, so matrix of the coefficient matrix. Okay, this is called, this part is coefficient matrix. So determinant of this equal to 0. Okay, determinant of matrix equal to 0 for non-trivial solution. So this determinant is going to be 0. We'll solve it now. So it is going to be 1. We know how to solve it. This one, this is 2 to the 4c minus 3b, right? Minus 1. This one get cancelled. This is 2c minus 6. 2c minus 6 plus 1. So this will get cancelled. B minus 4. B minus 4. Okay. B minus 4 equal to 0. So this is a non-trivial solution, right? So the determinant, because the non-trivial solution means rank is less than n, and if any matrix rank is less than the order of matrix, that means that matrix is called similar matrix, matrix, okay, and that similar matrix means the determinant of that matrix is 0, okay. That is the definition of similar matrix, okay. So this is going to be 4c minus 3b, okay, minus 2c plus 6 plus 1 b minus 4 equal to 0, okay. So this is going to be 4c minus this is going to be 2c, and b is going to 2b, and this is going to be plus 2 equal to 0. This implies 2c is going to be 2b minus 2, right? So in that case, so implies that 2 get cancelled, b is going to be c plus 1, okay. So this is the condition, right? So in this option you can check which option is matching. Option C, right? Option C is matching. So b equal to c plus 1. This is the condition. Now we have to find out solution, corresponding solution as well, because this matrix equation has a non-trivial solution, right? So we need to find out the corresponding solution. This is the condition we have found, okay. So because there is only here we can see in condition b equal to c plus 1, right? So c is obviously correct answer, but now we'll find out solution as well, okay. I will explain how to find solution also. So for solution, what we have to do is, for finding the solution of the matrix, okay, because this matrix is the coefficient matrix, right? Because right hand side is 0, homogeneous, it is a homogeneous matrix, right? Because right hand side is 0. So for that, what we are going to do is, we are going to we are going to convert this matrix, right, into the coefficient matrix into upper triangular matrix, right? Okay, so we'll write this matrix first. This is going to be 1, 1, 1, 1, 2, 3, 2b and 2c, okay. This is the matrix. So we know what the definition of upper triangular matrix, right? Upper triangular matrix means the whose all elements below the diagonal line are 0, called upper triangular matrix, okay. So these terms should be 0. So we have to make these 3 terms 0, okay. How we are going to do it? We'll do operation. I'll tell you how to do it. We have already done these operations in determinant and matrices in class 11th and 12th, okay. Well, so first operation we are going to, these are rows, these are columns, right? This is row 1 R1, this is R2, this is R3, okay. So we are going to make operation. So we are going to make operation in R3, okay. So R3 we are going to make R3 minus 2R1, right? Because if we do this operation, this element is going to be 0, right? R3 minus 2R1. Second operation we are going to do in second row, that is R2 tends to R2 R2 minus R1, okay. R2 minus R1. This will also get 0, right? So after operation, this matrix is going to be, first row will remain as it is, 1, 1. Second one is this R2 minus R1 means 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, okay. And similarly this one R2 minus R2 minus this is R3 minus R1, right? Sorry, yeah, R3 minus 2R1. So R3 minus 2R1 means this minus 2R1, this is 0, and this is going to be B minus 2, and this is going to be 2 into C minus 2, okay, 2 into C minus 2, because this one 2 2C minus 2R1, that is 2, right? 2 into C minus 2. This is the one because it is 2 is also there, right? 4. This operation. Now again we'll do the operation, okay? Because these two terms are 0. Now we need this term to be 0 as well, okay? So again we are going to make an operation. So this operation is R3 dash to R3 minus B minus 2 R1 as B minus 2 R2, right? R3 dash to R3 minus B minus 2 B minus 2 R2, right? This is going to be 0. Then B minus 2 minus B minus 2 R2. So this term will be 0 now. So after that the matrix is going to be 1 1 1 0 1 2, and this will become 0, this will become 0, and this is going to be 2 into C minus 2 minus 2 into B minus 2, okay? 2 into B minus 2. This matrix will become, okay? So now this we can see this is the upper triangular matrix, right? Yes, because this is the diagonal line, right? We can see below these all elements below these diagonal line are 0, okay? So for getting solution, first we need to convert this matrix into upper triangular matrix, which we have already done now. Now what we are going to do is now we'll write this equation for it, right? So now we have to find value of x and y, right? So this is going to be this one. So we can write this equation like this one, x1 plus x2 plus x1 x plus y plus z equal to 0 from this matrix, right? We'll take first two rows, right? We'll write in matrix in equation form. So this is going to be x plus y plus z equal to 0, okay? 0. Second is going to be 0 plus y plus 2z equal to 0. So we can write y plus 2z equal to 0. Okay, this is equation 1, this is equation 1, which we have got from this matrix, right? X plus y plus z equal to 0, and x is 0, right? Then y plus 2z equal to 0. So from 2 we can get y equal to 2z, right? Let's say z equal to k, okay? It means y is going to be from equation 2 y is going to be, this is minus 2z, okay? Going to be 2k minus 2k. Now we will put z and y value in equation 1. From 1, value of x is going to be x minus 2k plus k equal to 0, right? It means value of x is going to be k, right? So now we have got value of x, y, z, right? So it means x is going to be, x is going to be, capital X is going to be k minus 2k, okay, and k, right? We can write like this. So this means x is going to be, that is x, y, z values. Now we'll change it, right? This one. So this is here, this value is going to be like this, 1 upon root this k square minus 2k square, k square, right? So root k square plus minus 2k square root plus k square, okay? And we'll take k outside, and k outside, and this is going to be, this value is k is 1, k is taken outside, 1 minus 2 1, okay? 1 minus 2 1, okay? So this is going to be x equal to, this is 1 upon root 6, because k square we have taken out from root, so the k will get cancelled, 1 upon root 6, and this is 1 minus 2 1, right? This implies value of xyz is going to be 1 upon root 6 into 1 minus 2 and 1, right? So this is the answer. Which option is matching? Let's see. Obviously, see, we have already found that answer, right? By first condition, that is by getting the condition for non-trivial equation, non-trivial solution, right? So this one, which option? That is C, this one. B plus C equal to this, x value of x, y, z equal to 1 upon root 2, 1, 1 minus 2. This one. 1, 1, 1 minus 2, right? This one. So this is the one. Here I think we have made some mistake. For C, the options are 1 minus 2, 1, okay? So options are 1 minus 2, 1, okay? So option C is the correct one, okay? So option C is the correct one. Okay, this is the question which I was not able to solve in last lecture because of technical error. My class was ended. Okay, so next question which we are going to solve. Next thing we are going to solve. Okay, very important questions these are. This is a function of matrix. Okay, so how to find function of matrix? There's a procedure for that, which I will tell you, so that you can easily solve the functions of matrix. Okay, okay, so just do it. Yeah, so this is function of matrix. Function of matrix. For example, like we calculate value of A. This is the matrix, right? Any function of A. Okay, A is the matrix. So like for example, A is matrix. Okay, A is the matrix given. Okay, and function of matrix means FA. Okay, and FA can be like e to the power A. This is function of matrix. Can be e to the power 10. Can be cos A. A is the matrix. Okay, or pi A upon 6. Those are the functions of it. So we can find how to find the value of these function of matrix. Okay, so there's a procedure for that. Then you can and very good procedure and short procedure by which you can easily solve these type of questions. Okay, very important because many questions has been asked in Jest and other physical science exams. Okay, so for example, I'll show you. If A is given 1 1 1 1, okay, so this is the matrix. Okay, and we know the eigenvalues of this, right? Because this is identical matrix, so we can see their rows and two rows are equal, identical, or two columns are identical. Okay? This is called identical. If any matrix two rows, right, or two columns are identical, so in that case the eigenvalues is trace A 0, right? This is the eigenvalue. So we know that those property I have already explained. So this is going to be lambda equal to trace A means sum of diagonal elements. Sum of diagonal elements. So 1 plus 1 comma 0, right? 0. So this is going to be 2 comma 0. So we don't need to find the values of lambda eigenvalues by the method, right? By the method of like by using characteristic equation. If we know the property, we can directly know the eigenvalues. Okay, or directly find out the eigenvalues. Okay, so this is the eigenvalues are this. Okay, A is given and we have to find out. A is given and we have to find out. This is a take as a question. Okay, this is a question. A is given and we have to find e to the power a. Okay, and for that first we'll find eigenvalues. Okay, so which I have already found, that is eigenvalues lambda are equal to 0. After finding lambda eigenvalue, we'll write like this. So we'll write e to the power a equal to, we'll write alpha naught I plus alpha 1 a. Okay, this is equation number 1. And similarly we can write e to the power lambda, this is eigenvalue, equal to lambda naught plus alpha 1 lambda. This is equation number 2. Since values of lambda are, we have found, that is eigenvalues are 0 to, now we have to find out value of alpha naught and alpha 1, right? Simple. And then we have to put a value of alpha 1 and alpha naught in the equation 1 and we'll find the value of a. Very simple. Okay, so for finding now we'll write for lambda equal to 0. Okay, we'll put for lambda equal to 0, equation 2 will become equation for lambda equal to 0, equation 2 is going to be e to the power 0 equal to alpha naught plus lambda 1 into 0, right? It means e to the power 0 is 1. E to the power 0 is 1. Alpha 0, alpha naught plus 0. This implies alpha naught equal to 1. Similarly, we will find for lambda equal to 2, equation 2 is going to be this is equation 2, right? So this is e to the power 2, e to the power 2, e to the power 2 is going to be e to the power 2 going to be, value of alpha is, alpha naught is 1 plus this one alpha 1 lambda, right? Alpha 1 lambda is 2 alpha 1. Okay, so this means 2 alpha 1 is going to be e square minus 1 and alpha 1 is going to be e square minus 1 by 2. Okay, square minus 1 by 2. So this is the value. Now the value of alpha 1 and alpha naught we have found. Alpha 1 is this and alpha naught is, we have found, that is alpha naught is this one, this, right? We'll put these values in equation 1. Okay, from equation 1, so e to the power a is going to be, alpha value is 1, that is I plus, is going to be I plus alpha 1 is e square minus 1 by 2 into a, right? In this equation we have put this equation. Okay, so this equation is going to be, now this is going to be e to the power a, e to the power a equal, I is I value is 2 cross, this is 0 1 0 0 1 identity matrix, plus e square minus 1 upon 2 and this value is 1 1 1 1, value of a is, right? So e to the power a is going to be, if you solve it, this is going to be e square plus 1 by 2 square plus 1 by 2, this is e square minus 1 by 2 and this is e square minus 1 by 2 e square plus 1 by 2. Okay, this is the value of, equation. Okay, this is the required answer. Okay, next question, a very good question. Okay, so there is a procedure which I would like to repeat for you. What we have to do is we have to write this equation for 2 cross 2 matrix. Okay, this is e to the power a equal to alpha naught I plus alpha 1 a equal to 1. So this is equation 1, and then e to the power lambda equal to lambda naught alpha naught plus alpha 1 lambda. Okay, and we'll find eigenvalues for matrix, and we'll put these values in equation 2 and find the value of alpha naught and alpha 1, and then we'll put these values of alpha naught and alpha 1 in this equation 1, and we'll get the required solution. Okay, next question. This is also very good question. So for same, so the question is to a same, that is 1 1 1 1. This is the a given. Okay, and we have to find out sine pi a is the matrix. Okay, pi a upon 4. Okay, this we need to find. So simple, again we'll do the same. That is first this function of a, that is pi a upon 4. Let's see, this is equal to, we'll see this is equal to alpha 1 I plus alpha naught I plus alpha 1 plus alpha 1 plus alpha 1 a, right? This is equation number 1, and similarly second equation is going to be sine pi lambda by 4, will replace a by 4, is going to be alpha naught plus alpha 1 lambda. This is equation 2. Okay, so in general we can write like this for 2 cross 2 matrix. This is function of a equal to alpha naught I plus alpha naught I plus alpha 1 a, and second function of lambda equal to alpha naught plus alpha 1 lambda. Okay, this is formula, general formula for 2 cross 2 matrix. For this is going to be this. Now we'll find the eigenvalues. Eigenvalues are, because this is the rows and columns are identical, right? So this means eigenvalues are lambda equal to trace 0, right? So 2 comma 0 is the eigenvalues for this. Okay, so now we'll put the lambda equal to 0 in equation 2. Okay, so this is going to give, so sine 0, lambda is 0, right? Sine 0 is going to be alpha naught plus lambda equal to 0 is alpha 1 into 0, right? So this value is going to be sine 0 is 0, right? Alpha naught is going to be, value of alpha naught is going to be 0. Value of alpha naught is going to be 0. Next, for putting value of lambda, putting lambda equal to 2 in equation 2, right? So in that case, what is going to be like, in that case this is going to be sine pi lambda equal to 2 upon 4, this one, right? Lambda, in place of lambda we have put 2, and this is going to be alpha naught. Value of alpha naught we have found right now. Not alpha naught, value of alpha naught is 0, so it is going to be 0 0 plus alpha 1 lambda value is 2, right? So this is going to be sine pi by 2 sine pi by 2 is going to be 2 alpha, right? Sine pi by 2 value is 1, we know sine 90 value is 1. This is 2 alpha. This implies alpha equal to 1 by 2. Now we'll put value of alpha naught and alpha 1 in equation 1. So this is going to be sine pi a upon 4. Sine pi a upon 4 is going to be this one. Alpha naught is 0, right? So 0 into I naught plus alpha 1 value is 1 by 2 into a. Value of a is 1, 1, 1. Okay. So then the value is going to be sine pi a upon 4. Okay. This is going to be I is 0, right? This is 0 matrix. It is going to be 1 by 2, 1 by 2, 1 by 2, 1 by 2. Okay, this is the matrix. Or simply we can write 1 by 2 common and then 1, 1, 1, 1. Okay, so this is the answer. So now how to find the value of, if matrix is given, and if we have to find the value of function of any matrix, so how to find that value, I have already explained now. Okay, I hope you have understood it. Okay, next. Next is, this is also very important. Okay, so this is going to be last lecture of matrix, and then we are going to in next lecture we will start differential equation. Okay, which is also very important chapter of mathematical physics. Next is non-homogeneous homogeneous system of equation. If we have been given non-homogeneous, okay, so non-homogeneous non-homogeneous system of equation, okay, non-homogeneous system of equation. Okay, so here I'll explain. Okay, so if non-homogeneous equation is there, so what to do? Okay, if it is non-homogeneous, right, I'll make a chart for this. Okay, so for this, like this. Okay, if RA rank of equal to rank of C, I'll tell you what is C. Okay, rank of C. I'll give the example. As of now, I'm just writing, note down. Okay, second is if RA rank of A not equal to rank of C. Okay, rank of A not equal to rank of C. Okay, in that case, it is called, in that case the equation has inconsistent solution. Okay, inconsistent solution, or we can say solution does not exist. Inconsistent solution means solution doesn't exist. Okay, solution doesn't exist. Okay, this is the case. Second is if R equal to RC, rank of R equal to rank of C. Okay, in that case, infinite number of solution it has. If that will be the case, then the equation has infinite number of solutions, or we can say non-trivial solutions. Okay, non-trivial solution, or we can say non-trivial. Non-trivial. Okay, and this will divide this into two parts. Okay, The first part is so if R equal to RC, and in that case, yeah, this one, if RA, so we don't need to write like this, simple. If RA equal to RC and rank is, and rank of RC and rank of A is less than N, in that case it has infinite solution, non-trivial solutions, okay. And second case is, here second case is, if RA equal to RC, but and also the rank of RA and rank of C equal to N, order of the matrix, okay, for N cross N matrix, in that case it has unique solution, okay, unique solution, that is trivial solution, okay, unique solution, unique trivial solution, okay, unique solution or unique trivial solution. Now I'll explain it, okay. I will give example, then it is going to be clear to you, okay. Unique trivial solution, unique trivial solution, okay. Okay. Okay, for example, I'm giving, first I'll give you the non-homogeneous system of equation, okay, system of equation of matrix. So this is like, for example, we have x plus y plus z equal to 1, okay, and second x plus 2y plus 2z equal to 1, and x plus y minus z equal to 1, okay. We have this equation. So this equation, we'll write this equation in matrix form. So here it is going to be, A is going to be 1 1 1 1 2 2 1 1 minus 1, okay, and C is going to be 1 1 1 1 2 2 1 1 minus 1, this is 1 1 1, okay. This is A equal to 1 1, okay. So C equal to this, okay, this is the matrix, okay, in this form 1 1. So this matrix is called coefficient matrix, okay, coefficient matrix. And this matrix is called augmented matrix, okay. Augmented coefficient matrix, and this is augmented matrix, okay. So this is the matrix C, okay. So rank of this rank of matrix C means this matrix we are talking about. Rank of A means this coefficient matrix we are talking about here, okay. It has two parts, okay. The first part is this, second part, right. Now you understood this is coefficient matrix, this is augmented matrix, right. So here rank of A equal to rank of C, that is rank of coefficient matrix equal to rank of augmented matrix. If it is less than n, means order of matrix, in that case the number of solution, there would be infinite number of solution, means non-trivial solution. If this is equal, then unique solution, unique trivial solution, okay. Now I will solve question, then it will clear your doubt, okay. Question is x plus y plus z, x plus y plus z equal to 5, okay, and x plus 3y plus 3z equal to 9, and x plus 2y plus alpha z equal to beta. Okay, this is the equation which is given, and this system of equation has infinite number of solution. Infinite number of solution means non-trivial solution. Non-trivial solution means the rank of A equal to rank of B less equal to n. Okay, so infinite number of solution has infinite number of solution, and the value of alpha and beta we need to find out. Okay, this is the question. So infinite here, right? This chart is very important. If infinite solution, if equation has infinite number of solution, means non-trivial solution, then rank of A equal to rank of C less equal to n. Okay, here if system of equation has unique solution or trivial solution, then rank of A equal to rank of C equal to n. Okay, so it is given infinite number of solution, non-trivial solution means, and we need to find out value of alpha and beta, right? So for that, our first aim is to first we'll make a matrix. Okay, so matrix is the matrix of that augmented matrix is going to be 1 1 1 5 1 3 3 4 sorry 9 and 1 2 okay 1 2 alpha is equal to beta, right? So this is the C. Okay, so C is this one, right? 1 1 1 5 1 3 3 9 1 2 alpha beta. Okay, this is the C. Okay, in this matrix, because it is non-homogeneous equation. Why it is non-homogeneous equation? Because right hand side is not 0. Okay, okay, so now here we are going to do the operation. So our aim is to convert this matrix into this part, to convert this part of the matrix into upper triangular matrix, right? Means these three terms we have to make it 0. Okay, then we can easily find out the value of alpha and beta. So same again we'll do the operation. So what operation we are going to do? First we are going to operate R2 in this is row 1, row 2 and row 3, R1, R2 and R3. So R2 for making this 0, this is going to be R1 minus R2 minus R1, R2 minus R1. Second operation is R3 tends to R3 minus R1. Again it will become 0, right? So by that the matrix is going to be this is going to be 1. First row will remain same. Okay, 5. Second is going to be 0 2 2 4, and third is going to be 0 2 2 4. Yeah, that's correct. And then 0 1 alpha minus 1 and beta minus 5 by this operation. Okay, R2 tends to R2 minus R1 and R3 tends to R3 minus R1. Next operation, again we'll do the operation because now we have to make this is also 0, right? So this is going to be R3 tends to R3 minus R2 by 2. If you do that, this term is also going to be 0. So this is going, this then matrix is going to be 1 1 1 5, and this is 0 2 2 4, right? And this is going to be, this part is 0 0, and this is going to be alpha minus 2, and this is going to be beta minus 7. Okay, because we have done this operation. Okay, R2 by 2, right? So this is the one, and next is, so now you can see this matrix is converted. We have converted this part of the matrix into upper triangular matrix, right? And now it's easy. Now we know because it has, since it has infinite number of solution, okay, that implies the rank of A is, that implies the rank of A equal to rank of C is less than n. Less than n means if rank is less than n, that implies this matrix is similar matrix, or that means determinant of A is 0. Or we can say, for being determinant 0, this term should be 0. This term and this term should be 0, right? Then this part of matrix is going to be 0, right? So simple. So this means alpha minus 2 is going to be 0. If this term will be 0, then this part matrix of the determinant of this part is going to be 0. For this, if this will be, this should be also 0, then this determinant of this complete part is going to be 0. So this is 0, alpha minus 2 equal to 0, that implies alpha equal to 2. So alpha equal to 2, and similarly beta minus 7 equal to 0, right? So beta is going to be, implies beta is going to be 7. Okay, so alpha beta values are 2 and 7. Okay, this is the one more question. Next question is, this is the last question of the matrix. Okay, next question is, A is given 1 1 1 1, okay, and we have to find A to the power 10. Okay, so there are two questions actually. So it's just a question, okay, not one question. There is one more question as well. So this is A to the power 10 we need to find out. Okay, simple. We can see, very simple, right? This is because this is the rows and columns are identical. It means the value of lambda is going to be trace A 0, right? That is 2 comma 0. Trace means sum of diagonal elements, right? This one, 1 plus 1, that is 2 0, right? This I have already explained. And so simple, again we'll write. I have already explained this type of question. Two questions I have already solved. This is the third one. So this is going to be A to the power 10. You will write A to the power 10 equal to alpha I, alpha naught I plus alpha 1 A, right? This is equation 1. And similarly, lambda to the power 10 is going to be alpha naught plus alpha 1 lambda, right? This is equation 2. Now for putting a value of, lambda equal to 0 into, right? So this is going to be 0 to the power 10 equal to alpha naught plus alpha 1 into 0, right? This implies alpha naught equal to 1. Sorry, alpha naught equal to 0. 0 to the power anything is 0. this is 0. Similarly, putting alpha equal to 2, lambda equal to 2 into in equation 2, in that case it is going to be 2 to the power 10 to the power lambda equal to 0 plus alpha 1 into 2, right? So 2 alpha 1 equal to 2 to the power 10 implies alpha 1 equal to 2 to the power 9, okay? Because alpha 1 equal to 2 to the power 10 upon 2, so this is 2 to the power 9, right? So this means the matrix is going to be, putting this value of alpha naught and alpha 1 in equation 1, this is going to be a to the power 10 equal to 0 into I, this equation, right? This one, 0 into I plus lambda, this is 2 to the power 9, and then matrix 1, 1, 1, 1, right? So e to the power 10 is going to be 2 to the power 9 into 1, 1, 1. This is the answer. Okay, this is the answer. Well, this is the one. Next question. Last question, okay, for the matrix. And this question is very good question, guys. A equal to 1, 1, 0, 1, okay. And you need to find out e to the power a, okay. So here it's very good one. So here we'll find out first of all values of. So we can see this is upper triangular matrix, right? Why? Because the elements below this diagonal element, this diagonal line is 0, right? So upper triangular matrix. So we know if there is an upper triangular matrix, it means the value of lambda are diagonal elements, right? So this 1 and 1. So you can solve using a minus lambda I characteristic, a minus lambda I, determinant of a minus lambda I equal to 0 as well by characteristic equation, that is lengthy, right? If you know the properties, we can easily write the eigenvalues. So properties are very important. We can solve few questions very quickly if we know the properties, okay? So lambda equal to 1, 1. So it means here is trick. So we'll write e to the power a is going to be, because values are same, right? So e to the power a is going to be alpha naught I plus alpha 1, alpha 1 a. This is equation 1. Equation 2 is going to be lambda to the power a, e to the power lambda. My apologies. This is going to be e to the power lambda equal to alpha naught plus alpha 1 lambda, and equation third is going to, will differentiate this equation, okay? So this is going to be e to the power lambda, the differentiation of e to the power lambda is e to the power lambda, and this is going to be 0, right? And this is going to be alpha, e to the power lambda equal to alpha, equation number 3. Okay, this is very important if eigenvalues are same. Only by because only by this equation you cannot solve. Now for lambda equal to 1, equation 2 is going to be, for lambda equal to 1, putting lambda equal to 1 in 2, this is going to be e to the power 1 equal to, this is e to the power 1 equal to alpha naught plus alpha lambda, right? Alpha naught plus alpha 1 into lambda 1, right? So this is going to be alpha naught plus alpha 1 equal to e. This is equation 4, okay? So now we'll put this value of alpha equal to value of alpha 1. Value of alpha 1 equal to e to the power lambda, right? So now putting again what we are going to do is for lambda equal to 1, putting lambda equal to 1 in equation 3. In 3, so this is going to be alpha 1 equal to this, alpha 1 equal to e to the power alpha 1 equal to e to the power lambda, that is 1 So that implies alpha 1 equal to e to the e, right? Now we'll put the value of alpha 1 and now alpha 1 we got it. Now we'll put value of alpha 1 in equation 4. Then alpha naught plus e equal to e get cancelled, alpha naught equal to 0. So value of alpha naught and alpha 1 we have found. It means e to the power lambda. Will put these values in equation 1. Alpha naught 0, that is 0 into I, plus alpha 1 is e and ea, that is 1101, right? So this is going to be E1101. Okay, this is the answer, guys, right? So here because eigenvalues are same, so you need to do you need to differentiate equation 2, right? You will get equation 3. Now you will put lambda equal to the value of lambda in equation 2 and equation 3, and then you will find value of lambda 1 and lambda 2, right? Very good question. Well, guys, matrix is completed here. Okay, I'll solve some questions related to matrix as well. So in next chapter in mathematical physics, we will start differential equation. Okay, and also, guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are free of charges, absolutely free of charges, and are going to help you to crack the exams related to physical science. Okay, okay, guys, thank you so much. Bye now.